This is what the Wizard X220 looked like and weighed in at towards the end of 2018. And if you subtract the weight of the Hawkeye Firefly micro camera and the associated mount of 26 grams, you're left with an all-up weight minus the battery of 399 grams. And this is how it looks now. That's right. At the start of the new year, we decided it's time for the Wiz to lose some weight. So we've stripped it down to its base plate, and we're going to build it back up with some new, upgraded, and lighter components. Stay tuned to find out how much weight we can shed off the X220 and what she looks like in the end. Let's do this. Alright, we're going to be replacing old components of the X220 with new and upgraded components, and in some cases we're not even going to replace the components, we're just going to do away with the old components. So right now we're going to weigh the old components versus the new components and find out what weight savings we're going to get. The X220 has these side plates on it. We're not going to be using those. So that's a savings of 10 grams right there. We're going to be replacing these standoffs between the base plate and the top plate, which are 35.28 millimeters in length. And there's 6 of those. We're going to be replacing those with these standoffs, which are 29.67 millimeters in length. So the 6 35 millimeter standoffs weigh 8 grams. And we're going to be replacing them with 6 of the 30 millimeter standoffs, which come in at 6 grams. So that's a 2 gram savings there. So between the side plates and the replacement of the standoffs with the 35 millimeter standoffs with the 30 millimeter standoffs, we've already saved 12 grams. Then we're going to be replacing this RunCam Swift camera and the brace that holds it, which weight comes in at 22 grams, with a 3D printed micro mount and some sort of micro camera. Right now I've got the CAT-X Micro F1. I'm not convinced I'm going to use this one, or I may end up using a different one, but they're pretty much the same. And all that total comes in at 5 grams. So 22 grams minus 5 grams, that's a savings of 17 grams, plus the 12 grams, that's 29 grams so far. This is the F3 flight controller, the power distribution board, ESCs, and the VTX, the original VTX, which is the Eachine 48 channel 200 milliwatt VTX. All this comes in with a weight of, see if we can get it all on there, 41 grams. We're going to be replacing that with an RDQ Mach 2 VTX, an Ori 32 4-in-1 ESC, and a CL Racing F4 Mini flight controller. That comes in at 20 grams. 20 grams versus 41 grams. It's a savings of 21 grams. So we'll put it together and see how it turns out. Since we're going from a 30 by 30 power distribution board and a 30 by 30 flight controller to a 20 by 20 ESC and flight controller, we're going to need a mount adapter which goes from 30 by 30 to 20 by 20 for our install. This particular adapter is a Speedy FPV flight control mount adapter, and it actually comes with 2. The one on the left is 0.35 millimeters thick and the one on the right is 1.5 millimeters thick. They're made of fiberglass. It also comes with the associated hardware necessary. We're going to use the 0.35 millimeter fiberglass mount for our build, and the ESC is going to sit right on top of it.
These mount adapters convert a 30 by 30 mount to either a 20 by 20 or a 16 by 16 mount. I'll make sure and include the product link for these mount adapters in the video description below. In fact, what I'll do is I'll make sure and include all of the product links for all of the components that we use in this particular build in the video description below. All you have to do is scroll down into the video description and you'll come across a term. You actually see the term product links. Right below that, there'll be a URL link for each one of the individual products. Now we'll go ahead and install the 0.35 millimeter mount adapter with the associated M2 hardware to include M2 screws and spacers. Now we need to secure it down onto the M3 screws of the base plate by installing the M3 nuts. Now we can go ahead and install the 4-in-1 ESC on top of the mount adapter with the 8-pin connector for the flight controller facing forward and the solder pads for the XT60 LiPo power leads facing to the rear. And we'll go ahead and secure that down with some M2 spacers with threads on top to mount the flight controller on top of the ESC. And then after we go ahead and extend the motor wires, solder the motor wires on each of the pads for the ESC, go ahead and mount the flight controller on top of the ESC like that. Or I'm not actually sure the orientation of the flight controller at this point. I just wanted to show that that's how it would go, like that. Probably want the USB port to be going out of one of the sides, either like this or like this. In order to determine the proper length of the wire for the motor's extension to the 4-in-1 ESC, we're going to have to place the motors on the arms. And prior to doing that, we're going to go ahead and use motor soft mounts. And the product link for these soft mounts will be in the video description below. Whenever you're installing motors, make sure that the motor screws you're using are the proper length so that the tops of the motor screws themselves are not too long where that they're touching the motor windings. If that's the case, you'll end up burning out a motor or possibly an ESC. Now we can measure the actual length of the wire that we need to run from the motors to the 4-in-1 ESC, and we want to make sure that we leave enough slack in the wire length so that it sits nicely and neatly on the frame arms. Okay, we've measured and cut the appropriate lengths of the motor wire extensions. Now we're going to tin both ends of the motor wires and solder them onto the existing wires of the motors. We want to make sure and add heat shrinks over each of the solder joints that we make to protect them. And then we just want to go ahead and solder each of the extended motor wires to the appropriate solder pad of the 4-in-1 ESC. Outside motor wire to outside solder pad, inside motor wire to inside solder pad, and the middle motor wire to the middle solder pad. And also solder the XT60 leads to their solder pads. Next, we want to do a continuity check on our work so far by putting the multimeter in continuity mode and putting the multimeter leads on the ends of the XT60 terminals. If we do not hear a tone, that's a good thing. If we do hear a tone, then we've got a short somewhere in our work. Perhaps solder pads are connected to each other when they shouldn't be, or something of that nature. And that's a good sign. No tone. And the last check we want to do is to plug an actual LiPo battery into our quad at this point. Our Smokestopper, if the light bulb lights up, we have a problem. If it does not light up, we are good to go. And we can check to make sure that each motor and its associated ESC is working properly by observing whether or not the motor twitches when we actually plug in the LiPo. At this point, all 4 motors are twitching properly. The light bulb is not lighting up, and we're getting the proper 3 tones. So we are good to go.
Okay, after looking at the CL Racing F4 Mini flight controller diagram, it looks like normally the front of the flight controller facing the front of the quadcopter is this here, with the USB port facing out to the right side of the quadcopter. And there's no reason for me not to install it that way. You can go into Betaflight, and if you need to install it for some physical reason to rotate the flight controller, you can do that and rotate it in Betaflight to whatever direction you actually need to install the flight controller. However, in this case, there's no reason for me not to install it the way it was intended to be installed, so that is the way I'm going to install it. I've also taken a look to see if there's any need for me to make any soldering connections on the bottom of the flight controller prior to placing it on the mount, and there is not. I do not need to make any soldering connections on the bottom of this particular flight controller. So for now, I'm just going to go ahead and place this in its intended position on the mount. I'm not going to secure it down right now. The only reason I'm doing this is to make it easier for me to go ahead and solder the wires from the 4-in-1 ESC wiring harness to the flight controller, and also make the other necessary soldering connections, such as the receiver and the VTX. So this is just a placeholder. I'm holding the flight controller in place so that I can make the soldering connections more easily. Okay, now what we're doing is getting ready to make the connections between the ESC, the Ori 32 ESC, and the CL Racing F4 Mini flight controller. And the first decision we have to make is these connections need to go to this row of pads here. So do we want to go over the top and solder these wires down to the pads like that, or do we want to go underneath the flight controller and come up on this side? Well, I think the decision that I'm going to make is to do the latter, actually put the wires underneath the flight controller and come up on this side. And there's 2 reasons behind that. One, I don't want to mess with the gyro, having the wires hitting the gyro. And 2, this is the diagram of the flight controller, and this is the front of the flight controller. And there are more things that need to be attached to the front of the flight controller. 1, 2, 3, 4, 5, 6, 7. There are 7 wires that need to go attached to the front of the flight controller, as opposed to the back of the flight controller. There's only 4. So if I ran the wires from below the flight controller all the way across to here, then I've got 8 wires running across the front of the flight controller, and I would have to fit in these other 7 wires underneath them. That would be more difficult than if I came across the top and then I only had to connect these 4 wires to the back of the flight controller. So for those 2 reasons, I'm going to go ahead and run the wires underneath the flight controller, coming up the back, and attach them to these pads here. Which means I need to determine the length of the wires to cut them. And it looks like if I cut them to that length right there, they should be sufficient. So let's go ahead and do that. Okay, and what I'm going to do now is strip the ends off of each one of these wires. Then I'm going to go ahead and tin the wires and tin these pads. And then I'm going to solder the individual wires to each one of the pads per the diagram of the flight controller. And I have to compare that against the diagram for the ESC and the 8-pin connector, and to make sure that the wires in the connector are going to the appropriate pad on the flight controller. So you always want to double check that, because you don't want to mix up the connections. So that's what we're going to be doing right now. Strip the wires, tin the pads, connect the wires to the pads. Instead of going with the RDQ Mach 2 video transmitter, which we had weighed earlier, for this particular build I decided to go with this video transmitter. I'm going to go ahead and tin the wires so that we can solder it to the flight controller. And because of the wires going from the ESC to the flight controller on top, what I've decided to do is go ahead and solder these wires on the bottom of the flight controller before we mount the flight controller. Next, we're going to solder our RXSR receiver to the flight controller, and we've already attached the power and the ground leads. Power goes to 5 volts and ground goes to ground pad. What may not be as self-evident is the receiver has both an S port lead as well as an S bus out / CPPM pad, and also an S bus in pad. So what do we do with those? The S port is our telemetry data lead. The S bus out goes to the flight controller S bus pad, and the S bus in is only needed if you're going to have a redundant satellite receiver. Okay, now in order to bind the receiver to the transmitter, we're going to page up on our model and scroll up to binding, press enter, and we've got an RXSR, so we want telemetry on, and I'm going to go to the 16 channels. It's now in binding mode, the transmitter, and while this is beeping in binding mode, what we want to do is hold down the bind button on the receiver while powering it on. Let go of the bind button. Press exit on the transmitter to get out of the bind process. Unplug the battery and plug it back in. And now you can see the receiver is good to go. Solid blue and solid green light. So the receiver is now bound to the transmitter.
Telemetry lost.
As can be indicated by when I unplugged the receiver, you heard the transmitter warning say telemetry lost. Okay, so now what I've done is I've taken these 3D printed micro camera mounts, which the product link for these will also be in the video description below. They're very cheap. I think they're about $2.50 to $3 for a bag of 2 to 3 sets. I got them in blue and white. I just screwed them on with 2mm screws. Then you fold them like this and they go on the standoffs. So the reason I'm doing this now is I'm mounting the camera up front in the quadcopter so that I can have an understanding of how long the camera cables need to be soldered on these front 4 pads. These front 4 pads here of the flight controller. So I'm going to go and mount this. And right now I'm just putting it in place. So we've got an idea of how long the cables need to be from the camera to the flight controller. So we've attached the wiring harness to the camera, and I'm going to leave the remote cable harness that I can hook up the remote to and change the settings on the camera. I'm going to leave that inside the quadcopter, and all we're concerned about is the red, black, and yellow lines, red being power, black ground, and yellow the video. It's going to run to these three pads here. There's a fourth pad for OSD camera control, which I'm not going to be using. And I've pulled out one of the wires that came with this for a voltage sensor, because I'm not going to be using that. I'm not going to be using the camera to sense the voltage for that as well. So I've just got to determine the length of the three wires that I'm going to use to solder that to the flight controller, and we'll do that now. Looks to me like if I cut them right about here, I should be good. We'll give it a little bit of slack. So we'll make that cut. Then we're going to strip the end of the wire, get them ready for tinning, and then we're going to tin the wires and solder them up here to the front of the flight controller, the appropriate pads. Okay, there's one or two other components that I want to solder on to the quadcopter. The first one being this microphone, external microphone. It's fairly large mic, so it ought to get fairly good audio from the motors. The reason I'm using this is actually larger than the electric microphone which we put on the Ascent X 2.5 inch. But I'm using it in this quad because we're building a 5-inch quadcopter, and it's got plenty of room for a microphone such as this, and I happen to have it, so I might as well try it out and see how good of audio we actually get from this. If you're interested in this type of microphone, then the product link for this is going to be down in the description below. The microphone is advertised to operate off of 6 to 12 volts, but I've seen reviews saying that it operates off of 5 volts fine, so we're going to try it with 5 volts. There's a 5-volt pad and a ground pad up front here on the flight controller, right there and there. We've already tinned the wires for it. The audio wire gets connected to the audio in of the VTX, which is one of the reasons why we're using this VTX is because it's got an audio in. So we're going to solder these two wires together, and then I'm going to run the 5-volt and the ground between the flight controller and the ESC, so that it comes out the front like this, and then we can go ahead and solder these two to the pads on top of the flight controller, and then this will sit down at the back of the quadcopter on the base of the frame. That's the plan. And now that we've got the microphone soldered on to the VTX and the 5-volt and ground pads of the flight controller, I think that's going to do it for now. All we need to do is put the quadcopter back together and tape up the motor wires, check it out, see if it still runs, and get this puppy up in the air. Let's go put it back together. Okay, in putting this back together so far, I've gone ahead and screwed on all of the standoffs. So I've got 6 standoffs. I've also used this double-sided tape, put some of that on the microphone here, actually wrapped the microphone in it and stuck the microphone on the base plate using double-sided tape with the actual microphone sticking out the back. And hopefully I'm thinking that will protect it from some of the wind noise and still get motor noise from the motors. I've also placed the RXSR receiver here. I've put some heat shrink, transparent heat shrink over it and wrapped it in that. And then on the bottom, I've placed some of this double-sided tape on the bottom and stuck that to the base plate as well. The antennas, the receiver antennas, I've actually ran out the bottom. And I'll show you what I'm going to do with those, but basically I'm going to attach those on the back arm frames, on these back arm frames, facing this way and facing this way, with some zip ties and heat shrink, and that way they'll be underneath the prop levels, and in a crash or hitting a tree or something like that, they won't get tangled up in the props. And I learned that technique by watching a Joshua Bardwell video. He's got a good video on how he goes ahead and attaches his antennas to the quadcopter. So I'll be doing that. I've got this VTX antenna here, which is the Actuna Gem, and I've got that running through the circular area on the back of the top plate, so that's not going to fall either way into the props. And then I've got to wrap the motor wires in the Emax fabric tape onto the arms. So we'll be doing those and screwing the top plate back down to the standoffs and putting our props on. We're going to use different colored prop nuts than what are currently on here. We're going to put our props on, prop nuts, and that will complete our build. Screwing the top plate on to the standoffs. Now our next step is to go ahead and tape these motor wires down. Okay, to tape down the motor wires, I use this Emax, I think it's 8mm wide fabric tape. Comes in a pretty big roll for about $5, something like that. If I remember, I'll put the product description down in the links below for you. And that keeps the motor wires down and not get tangled up in anything that it might hit. I'm also going to put another piece right around here towards the base plate, and I'll do that for each of the arms. Alright, and that's what the motor wires looked like taped down. Not too bad. Now we're going to go ahead and use zip ties and heat shrink to place the receiver antenna in their spots. And that's how we do the receiver antenna. And I'll finish up the one on the other side over here. Okay, and that's what she looks like with the receiver antennas installed. Not bad. We'll have to find out when she flies, how she flies with them in that configuration. What I did, because the wires were not completely wrapped in heat shrink underneath, it's just that they're wrapped in heat shrink right here where the zip ties are. Underneath, they were just laying along the arms. So I went ahead and used some of the fabric tape that I used to tape down the motor wires, and I actually taped down the exposed cables for the antenna right here. You can see right here and right here. Now I think the only thing we have left to do is put the props on, put the prop nuts on. We're going to use new prop nuts, green and red. We're going to put on some new Dow Prop Cyclone 5046Cs. And remember, all of the motors are reversed. So we've got to put the props on in the correct direction for reversed motors, which would be like this for this one. And the way I can tell that I'm putting the props on in the proper direction is normally with the motors, I've got all the motors reversed so that they spin out away from the camera. Normally it's exactly the opposite. On normal spinning motors, this edge would be facing in towards the quadcopter main body. So on a normal spinning motors, this prop would go on this direction like that, and this prop would go on this motor facing in. So when you turn the props facing each other, this edge would be facing that way. Because these motors are reversed, it's just the opposite. We want that edge facing away, so that prop goes there, and this prop goes here. So those edges are now facing away.
Okay, what do we got? We got these red ones
Go on. These screw on the other way. Okay, let's see if I hold the motor and try to spin the prop, it ain't moving, which is what we want. We don't want this, when the nut is tightened down, we don't want the prop to be able to spin while you're holding the motor, because then the nut's not tightened down enough. Alright, let's see what we got here. That edge is facing away from the main body of the quadcopter, which is what we want. Feels like it's all the way down. That's not going anywhere. That's not going anywhere. That's not going anywhere. That's not going anywhere. Feels light, huh? Alright guys, take the camera lens off. The only thing we have left to do is weigh this puppy. Alright, when we first started, the Wiz weighed 399 grams without the Firefly micro camera mounted on it. 399 grams. Here's the moment of truth. 81 grams we got rid of. Wow, that's impressive. Good job, guys.
Next time, we'll go through our Betaflight setup and see how she flies. Until then, make sure to subscribe to your TMac FPV channel. Hit the thumbs up button if you liked the video. We appreciate your time and thanks for watching. Happy flying.